Hi, I'm Metta Spencer. I'm in Toronto, but today I get to go home. California is my home territory, and I get to speak to a friend who's in Newport Beach, or I guess you'd say Balboa Island, which is part of Newport
No,
Beach,
I,
I
I'm
think.
in Newport.
Are you in Newport? Good. Well, this
Yeah,
is Bill
I'm
Fletcher.
in Newport.
Bill is an engineer slash corporate executive, now slash retired. Is that fair enough?
That's fair.
Okay, now you are a bit of an expert on all things having to do with climate change. You've written this book. I see in the background we get to look at your the looks like the cover of your book. You've blown up.
It is.
Yeah, that's okay. And the thing I want to talk to you about today is this notion of tipping points, if you don't mind. It doesn't sound very ominous, but when you really learn what it means, it's pretty serious.
A tipping point, I think the most popular comment would be the straw that broke the camel's back. A tipping point would be a point at which you exceed some limit and the system breaks down. In engineering, it would be something like when a bridge or a building, when it's overloaded, you can overload it up to a point, and then it does not fall gracefully to the ground; it collapses. and so, and I think putting it in the context of global warming. To date, we've had what an engineer would say would be a pretty linear process. We put more greenhouse gases into the atmosphere, and the temperature goes up. You put some more in, and the temperature goes up a little bit more. But it stays in proportion to the CO2 and other greenhouse gas concentrations. So. As the greenhouse gas concentration in the atmosphere goes up, so does the Earth's temperature. However, what people are worrying about is that at some point something could break down, and you would get a much more rapid increase in global warming, or you would have something like the Amazon rainforest start to collapse, or namely the ice cap in Greenland, things like that. There's probably, I'd say, a dozen tipping points that the scientists tend to be concerned about, and we could talk about those. But it would be a case where this linear process, a little bit of an increase in greenhouse gases, you get a little bit of an increase in temperature, breaks down, and you put another straw on the camel, and he falls down, and that's what people are worried about. And I think one other comment is these what I'd call nonlinear events. Are very hard to predict. And so, when you look at forecasts of global warming, they do not include tipping points because people worry about them, but they don't know when they might occur or how serious they would be. And but we do know they're out there. And the more greenhouse gases we put into the atmosphere, the higher the Earth's temperature gets, the closer we get to some limit. And we could talk, there's several that we could talk about.
Okay. That is, I guess you talk about linear, then in my imagination, this graph that you've started drawing in my mind, it goes up and up and up at a certain rate, a steady rate, and then jaggedly jumps straight up practically. Is that the way it would look?
Yeah, and it doesn't have to be temperature. One of the areas of tipping point that people are worried about is the Greenland ice cap and the ice shelf in the Antarctica. And at some point, if they, like in Greenland, I think the process has been that in the summer, the ice cap melts, and in the wintertime, you get snowfall and things, and it builds back up. And, for centuries or more, the ice cap has been pretty stable.
Mm-hmm.
But if it starts to just continue to melt and doesn't reconstitute itself, let's say, in the wintertime, then you get a loss of water, and there's enough ice on the Greenland ice cap to, I think the estimate is add like 20 feet to the ocean depth. But that would take a very long time. But once the ice cap, and we may be there already, once the ice cap melts more than it replenishes itself, you will get a net loss of water that can accelerate the higher the temperature gets.
Mm-hmm. Well, I immediately start to think of other things where the straw that breaks the camel's back applies. I mean, I think of, I've heard people say that the ocean acidification, there are certain tipping points where you begin to lose coral for one thing, but many other species of life that can't survive in the same way. So it would have a chain reaction. And if the animal life that would be used as food for other animals, if it's gone, then all these other animals die, et cetera. So you'd have a runaway reaction just from the ocean, from too much absorption of CO2. Is that another fair example of the phenomenon?
Well, I mean, when you look at the ocean, there's probably two things to worry about. One would be, a significant amount of the CO2 in the atmosphere is absorbed by the ocean. And when that CO2 is absorbed, it reacts and forms, I think it's carbonic acid, but it increases the acidity of the ocean water. And that interferes with the shell formation of various ocean creatures. And that could affect the food chain for fisheries and so forth. So the acidification is an issue. And also just the temperature increase is having a big impact on coral. It's estimated that if we actually do reach the 2 degrees C global warming limit that the Ipcc has talked about, that we would perhaps lose all of the coral in the ocean. It would be bleached. And we're seeing that in places like the Australian Great Barrier Reef is already being heavily damaged. And that would affect, let's say, the fish population that depends on the coral reefs.
So that's another example of tipping points. Kind of
that would be another one.
Threshold you reach, and then it's a different game.
And there'd be two phenomena. One would be the CO2 absorbed by the ocean, increasing the acidity of the ocean. And then the other one would be just the temperature change has a big impact. And from what I read, coral is very sensitive to temperature. So a little bit more of an increase. We've already lost a lot of coral, and we'll lose it all if we don't stop.
Now, you say it's really hard to predict where the tipping points occur. That's disturbing. I guess I probably knew it, but I didn't know that I knew it. In other words, I never thought about it before. Now, are you saying that the Ipcc does not include tipping points in their projections?
That's my understanding. I mean, there's the forecasts that Craig and I have looked at do not explicitly include a tipping point. But they are discussed, and there's a lot more being published about them. And maybe would it be helpful to just review what some of the main tipping points would be?
Yeah, please.
I mean, if I was worrying about tipping points, I mean, I'm worried about the ocean acidification and the death of coral, but that's not the ones I would worry about the most.
Uh-huh.
I think that, a big one, the big ones are and this is not in order of importance, would be, first of all, the loss of ice or the collapse of an ice shelf. And there's two phenomena. In the Arctic, Greenland has a huge ice cap. And the question would be, and that's been very stable for a very, very long time. It melts in the summer and it refreezes in the winter and gets snow to build it back up. But if the Greenland ice cap reached some point where it just was melting a lot more than it was refreezing, that would be a slow increase in the ocean temperature and the ocean levels that we could not stop. And maybe it would take 100 years or more for the ice cap to melt, if that was possible. But it would, slowly increase the depth, the ocean level. The other one is in Antarctica. There's huge ice shelves that stick way out into the ocean, and they form a barrier so that as ice is formed in Antarctica on the interior, it prevents that ice from flowing into the ocean. But if those ice shelves are being undermined by warmer water, if one of them collapsed, then there would be a greater flow of ice from the mainland from the land into the ocean, and that would again have an impact on ocean levels.
Well, we know that some of those shelves have collapsed, maybe not the biggest ones.
They have, yeah.
But some of them, the size of a small U.S. state or something, have collapsed, as I recall.
I think that throughout history there have been. I mean, the ice sheets do build up and then break off on the edges. The question is, will there be a point where a much larger portion of the ice shelf breaks away, and the barrier to prevent glacial ice from flowing into the ocean is compromised, let's say.
Well, also,
another one,
a big chunk like that falling in, becoming an iceberg, eventually those suckers melt, and that is in itself lethal because it's going to raise the sea level, right?
Well, not really. I mean, the ice shelf, if you can visualize this, is already in the ocean. It's sticking way out. And so the ice is already, so if the ice melted, it would not affect the ocean level because it's already like a big iceberg. It's already floating and displacing the water. So whether you're displacing the water with ice or the melt, it wouldn't affect the ocean. What would happen is if these ice shelves broke up, then ice that is on the land would flow into the ocean, and that would raise the sea level. One thing is the ocean level and the impact of ice melting in Greenland or an ice shelf collapse in the Antarctic would have, and some of the other things that people are worried about would be, one is the Amazon rainforest. I mean, it's been described as the lungs of the earth. It absorbs the huge forest there absorbs a lot of CO2 from the atmosphere, and as that forest is destroyed, then that CO2 would stay in the atmosphere and increase global warming. A lot of that, the rainforest is being cut down, and then to compound the problem, they cut down the trees, but then to dispose of the trees, they burn them on site. Most of that is to create farmland, and most of that farmland is to raise cattle and food for cattle for beef production primarily. So I think something like 17% of the rainforest has been destroyed so far. And when you get to a tipping point, I mean, and so far that's been, let's say, a linear process. You cut down 1% of the trees and you lose 1%. but the rainforest generates a lot of its own rainfall. There's a lot of evaporation that then gets turned into clouds that turns into rain. And there's, again, the tipping point would be if you cut down too much of the rainforest, then the evaporation is much, much less, and it's not a rainforest anymore. And a lot of the trees would die, and it would become more of what they describe as a savanna, open grassland with scattered trees. And the Amazon would lose a lot of its ability to absorb CO2 from the atmosphere. And it's not just the Amazon. I mean, in Indonesia, for instance, cutting down the rainforest there to grow palm oil. And there's also a lot of tree cutting in parts of Africa as well. And in North America, we've already cut down our forests, so we're not. We did that a long time ago. So the loss of the rainforest would be one. I think another one would be, in the Arctic, there's two phenomenon. There's the tundra up there, and not the tundra, the permafrost, excuse me, and that is basically vegetation that has been rotting for I don't know, maybe 1 million years, and it's now permanently frozen. But that as that permafrost melts, it releases CO2 that's been sequestered there or captured there maybe 1 million years ago, and also it releases methane, which is a powerful greenhouse gas. So melting permafrost is one thing, and the other one is what they call the boreal forests. These are huge forests in places like Canada, Alaska, Siberia that are just below the permafrost. And again, these forests absorb a lot of CO2 and have a lot of CO2 sequestered in the forest. So if those forests die back or burn in a forest fire, they would release CO2 that has been, let's say, sequestered there for centuries. And we now know that this is a phenomenon, I think it's not well understood, that the Arctic is increasing in temperature at twice as the rate of the Earth. And so as the Arctic heats up, more of the permafrost melts, and there's more drying out of the forest up there, the boreal forest, which depends on being frozen 6 months a year in the winter. And we've had increasing forest fires in that northern, northern areas, which are bad. And I think one other, the monsoon. There's two big monsoons. One, the biggest is probably in India, where they get 90% of their rainfall in at one season of the year. When the monsoon comes in, and there's at the end of a very hot season, and rains, very intense rains for quite a while, and that's where they get their water for agriculture. And if the monsoon shifted or was delayed or was weakened, that could dramatically affect the food supply in places like India and Bangladesh, and have a major impact on the growing season there. And the monsoon is not just that it might not show up or be weaker, it could also be a lot stronger. I mean, if it is much more intense, there'd be flooding and things like that. There's also a monsoon in Africa, in West Africa, and that again could be affected, if the weather pattern there changed. And and that would have a big impact on the food supply that millions of people depend on. And one other big one that I think is worth talking about is the ocean currents, and mainly the Gulf Stream. As we know, the Gulf Stream is a terrific phenomenon. It takes warm water from the tropical areas, the Gulf of Mexico, and transports it all the way up to the Arctic. And that warm water actually leads to a milder climate in northern Europe as it heats up the air. And then when it gets to the Arctic, it leaves it, that heat that's been transported up there is then cooled off by the cold water up there, and the water as it gets colder, it's heavier, so it sinks to the bottom, and there's a reverse current below underwater that takes the cold water back toward the tropics. And so that's a little bit of, let's say, a natural air conditioning. But as ice melts up in the Arctic, there's more fresh water, which is lighter, and so the current is weakened, and that's a concern. At what point would it be weak enough so that it doesn't do its job or even stop? So those are the things that people worry about, and we can see they're very complex natural phenomenon that would be very hard to predict exactly how they'll behave.
I have some of them that worry me more than others. I guess if I were worried about them all, I'd be paralyzed. But but the one that worries me most is the methane and the permafrost in the Arctic. And I've really gotten interested in that. I was interested because last weekend or sometime recently, I think it was in the New York Times, was a long article, a glowingly optimistic article about how much Russia was going to benefit from climate change, because they're going to be able to use a lot of land for farming that they haven't been able to use up to now because of the permafrost. Yeah. They never once mention the whole problem of the methane being released from the melting permafrost. And that to me is the real nightmare, you know. Methane is the thing that totally keeps me awake at night. And I think also about the methane in the clathrates at the bottom of the Arctic oceans. That I understand that the Ipcc, maybe you've even already hinted that maybe they're not as drastic in their predictions as they would be if they took all of these tipping points into account, because up to now, they seem to think that, yes, the methane, the clathrates, these frozen crystals of methane and so on, water and on, that yes, they are melting and they will melt, but by the time they get to the surface, the methane will be absorbed by the ocean, and so don't worry about it. So they haven't really predicted that it is as drastic. You know, in other words, the implication was we have a long time to handle that, you know, maybe 100 years, 200 years before it'll really get to be too bad. But there's a guy in Britain recently who came back and said, yeah, it all depends on how shallow or deep the ocean is. And certain areas like the East Siberian Sea is pretty shallow. And yes, it does get to the surface and get into the atmosphere. And that's happening much faster than people predicted. So a tipping point that you can't, you know, that you don't know when it's going to happen. But I think you better be on the safe side and assume that the soonest that it might happen is the date that you better work for, you know, work with the idea of predicting that things are going to happen faster rather than potentially slower. What do you think?
Well, I mean, I think there's a couple of things. I mean, you say, well, the methane is released, but then it's absorbed by the ocean. and that just aggravates the problem we talked about early on about acidification.
Right, exactly.
I mean, that doesn't do the ocean any good.
Mm-hmm.
It's a different problem. And I think also, you don't know which one is going to be the worst, but if the permafrost melts, we're already seeing, I mean, we've had huge fires in the Arctic last season because of the drying out of the permafrost, and it doesn't burn if it's frozen. And this boreal forest, there've been huge forest fires in the Arctic, and the Arctic is heating up at twice the rate of the world on average. And there are places like Svalbard and where the permafrost is collapsing, and buildings are going under. So it's hard to tell which one we should worry about the most.
Yeah.
And I also think it's not going to be like a building collapse. I mean, let's say Greenland starts to irreversibly melt. Well, it might take 200 years for it to melt. But if you did that, you might see the ocean increasing at an inch or so a year for 200 years. And that's not catastrophic tomorrow, but it would be something that you could count on, and that would have a devastating effect over time.
Well, I've even heard somebody, I've forgotten who, it's been a couple of years, say that this ocean current thing, that can happen quite quickly. Apparently, there have been other instances, not necessarily of the Gulf Stream, but other places where a current can change, well, maybe not overnight, but within 10 years or less.
Yeah.
And something like that happening, and then what are you going to do about it? Is there anybody with a game plan? I mean, other than let's just keep our emissions down as low as possible. Are there specific interventions that people are proposing with respect to preventing each of these tipping points?
Well, I think that all of these things, let's say take the Gulf Stream or the monsoon or something like that. I mean, how would you prevent the monsoon from failing, or how would you prevent the Gulf Stream from slowing down? It's the only solution is to stop putting greenhouse gases into the atmosphere.
Well, that's not true.
That's the fundamental issue.
I'm sure of that. It's not just don't.
Other than that, I don't know what you could do.
Well, sure. You not only stop putting in there, but you do what you can to suck it out. The stuff that's already been in there, you want to take it out and bury it, or do something to sequester it. You have to increase the amount of reduction that you take out of the atmosphere. And there are other interventions, these geoengineering proposals. Somebody was just in the last week, I read somebody's going to start shooting. In this case, it's not sulfur; it's some other calcium or something.
Crystals into the atmosphere. Yeah.
Yeah. So that's different from just reduction of emissions. In fact, I believe for several years that it's already too late to save the world just by reducing emissions. It's we're too far along. So we have to do something like actually remove carbon from the atmosphere. Actively.
Well, Metta, Craig and I have looked at that very carefully. In fact, we have a blog post on removing CO2 from the atmosphere. And, Professor Hansen in the US, who's very famous for being the first to really warn about global warming, has looked into this. And we figured out, and in Canada, there's a Canadian company that's spending a lot of time and effort developing ways to remove CO2 from the atmosphere, and it can be done. But we just did a calculation for our blog, and this confirmed what Professor Hansen said, is that to take 1 part per million of CO2 out of the atmosphere. That's not a lot. That's 1 out of, let's say, 415, would cost about $1 trillion.
Yeah.
It's very, very expensive because the CO2 concentrate is not very concentrated in the atmosphere. And so you have to move huge amounts of air through a process to capture the CO2. Now, I think that CO2 capture might be viable at some point, for synthetic fuels. But the other thing is, if you took the CO2 out of the atmosphere, what do you do with it? You have to store it somewhere forever. And there's no economic value to this. You're not going to sell it to someone, so it's a pure expense.
Stick it in the soil. Agriculture is a wonderful tool for removing, if you do it right, removing carbon and putting it in the soil. All you have to do is stop digging it up and turning it over. And even in the ocean, there's this thing about sprinkling iron filings that's going to create all kinds of phytoplankton that will fall to the bottom of the ocean and sequester the carbon there. There are a bunch of ways. That's not expensive. Iron costs practically nothing. And even the geoengineering, as cheap as can be, it's really peanuts. But I don't know that I want to do it because there are all kinds of other things that might happen as a result. But the knock-on effects of doing it, I'm not sure. But it certainly, agriculture can do a hell of a lot, and forestry can do a hell of a lot.
Well, I mean, I think with forestry, I mean, I don't disagree. Well, there's two points I would like to make. One is, when you talk about geoengineering, putting iron filings into the ocean, you're basically fooling with nature on a very big scale. And there's no way you can do a controlled experiment. And so you don't know what the secondary and tertiary effects would be. I mean, maybe it gives you a benefit of some kind, but to do it on a scale where you'd have to remove many, many ppm of carbon dioxide, let's say, out of the atmosphere, it would take a huge amount. And I think if you look at the cost of these things, well, first of all, I think with geoengineering, there are a lot of risks that I would be very concerned about putting enough iron filings into the ocean to remove a significant amount of CO2. You might do some real damage to the ocean.
No, we know that. And I just conceded that at the outset, that it would be a risky thing to do. And especially this stuff about shooting it into the stratosphere. But if you really believe that there's a tipping point coming and it's irreversible, then do something drastic. I mean, I think you'd agree with this. I mean, basically, it's where the world is today. I mean, like a smoker. If you were a smoker and I'm your doctor, and I'm saying, hey, you're going to get cancer if you keep smoking, and you say, well, what else can I do besides quitting smoking? I think that's the same thing. The fundamental problem is we're putting greenhouse gases into the atmosphere at an increasing rate, and that's having a dramatic impact on our environment. IPCC has already, the IPCC already some years ago, rather quietly acknowledged that, yes, you can't solve the problem now just by reducing emissions. It's too late. You actually have to do some effective removal of carbon from the atmosphere. Now, how we're going to do it is a totally different question and a whole set of questions. But I think there are various things that can be done. Certainly biochar, for example.
Yeah. But if we can't agree on stopping putting it in the atmosphere, how do you think we'll ever agree on the cost and effort to take it out? I mean, I think that's even a bigger problem. Who's going to spend $1 trillion a year just to take 1 ppm of carbon dioxide out of the atmosphere? I mean, you'd have to spend many, many trillions of dollars, and that money could be much better spent on eliminating emissions in the first place. But
is it a choice? I don't think it is a choice anymore. I don't think it's a choice anymore. I think you have to do both. You certainly don't want to stop trying to reduce emissions. That is the key to the whole thing. But it's not enough now. You got to do more.
I mean, there's a couple of things. I mean, my personal opinion is that to remove CO2 or other greenhouse gases on a scale would be prohibitively expensive. I mean, but there are things we could do. I mean, you mentioned agriculture. I think the biggest thing is stop cutting down the rainforest and plant billions of trees. I mean, that could be done.
I agree.
That's a very good
not
thing
millions,
to do.
2 trillion. That's the scary
takes
thing, because that really is daunting when you think about how much a trillion is 1,000 billion. And when countries say, "Oh, goody, we're now being virtuous. We're going to plant 1 billion trees." Ha! Well, 1 billion is just a drop in the bucket. We need 2 trillion trees, and that is really going to be expensive and daunting and difficult. But I think we better get on with it.
Well, and I would also mention one other thing. I mean, the places where you'd plant most of the trees are in places like Brazil and Africa, and they have no incentive to do that. They're not the big contributors to global warming, and they don't have the resources, the money or the technology. So you'd need an international effort mounted by the developed countries to fund and support all of that tree planting. And then you'd have to buy the land, you'd have to plant the trees, and then it'd obviously be some maintenance to make sure that they're not destroyed, that sort of thing. So, I mean, there's big international efforts would be required no matter what we do. And I think the first order of, and there's no magic pill that we can avoid just stopping global warming by stopping putting greenhouse gases into the atmosphere in the first place. It can be done. I mean, it's happening very rapidly now, but just not fast enough.
Well, I agree on
we're
that.
Phasing out coal. Yeah. A lot of good things are happening.
If we agree on anything, and I think we disagree on a little bit, because I'm much more maybe alarmist than you are in terms of feeling that we got to do more drastic things about than just reduce emissions. But where we certainly agree on is that we need to speed up everything else that we're doing, and certainly the reduction of emissions is number one. And you guys are really on top of that. So, okay. Well, I guess maybe we agree on 90%. Let's see where we can go to narrow the gap between my alarmism and your sense that we can still make it by. You still believe we can make it by doing carbon emission?
No. I mean, Craig and I have looked at this a lot and done our own forecast. We don't think we're going to blow through the 2°C limit that is proposed by the Ipcc. I just don't see anything happening fast enough to stay under that limit. And so that says one other thing, and mitigation has to be a big part of the solution. I mean, we have done a lot of damage. If we stopped emissions tomorrow, global warming would continue because we aren't removing the greenhouse gases that are already in the atmosphere. So we've created a big problem for ourselves, and mitigation has to be a big part of the solution. But there's no magic pill that we can take other than stopping greenhouse gas emissions. Geoengineering and taking CO2 out of the atmosphere. I mean, these are things that I can't say they don't have merit. Let's continue to develop those things, but I just don't think there's going to be anything short, that's better than just stopping the emissions in the first place. Mm-hmm. And the sooner we do it, the better, because stopping emissions doesn't remove anything from the atmosphere. It takes a long time for CO2 and other greenhouse gases to dissipate naturally once we stop emissions.
We have every one of these tipping points that you've mentioned requires a whole conversation in itself. because
Yeah, absolutely.
I would love to. Right now, I'm looking at another video that I made on another screen right beside the one I'm looking at you. And this is a guy talking about his work in Siberia with people who are trying to stop the melting of the permafrost with the idea of reducing the growth of trees in the Arctic. And the way they want to do that is by importing big animals, because they say that what caused the change in the Arctic was the depletion of these megafauna at the end of whatever Pleistocene period it was. And we have to replenish big animals in order to stomp down knock over the little saplings and keep the forest from growing there. That's a whole conversation. In fact, it's two or three. It's worth two or three talk shows, and I hope I'll get another one on that topic, because I think it's really worthwhile. But that's just with the idea of what to do about the permafrost, and that's only a tiny fraction of it.
I think the number is 55 gigatons of CO2 into the atmosphere every year. And these efforts would be peanuts compared to the size of the problem. And so, I would just be very cautious to do the math first and see how big a deal would this be if it actually worked. And a lot of these things would be very small.
Well, I will acknowledge that right there. I mean, very interested in the notion of big animals knocking down trees. It just intrigues me. But nevertheless, I agree that the practicalities of getting that to happen are pretty daunting. And I wouldn't pin my hopes on that. But it is important to think in terms of what we can do if there's anything that can be done to slow the melting of the permafrost, because that thing can really be a runaway.
Stop emissions. Stop emissions. That's the big one. Yeah, I mean that.
I don't.
But I
don't think it's going to work. I don't think. I think it's too late to do that. That's a whole conversation. Let's look into it again and come back to this, Bill. I invite you. I will go do some more.
Can I mention one other thing before we end?
Huh?
I mean, one of the biggest emitters of methane in the world is cattle production. It's supposedly, up to 14% of greenhouse gas emissions. And if you're going to introduce all of these huge animals in the Antarctic, they're all going to be producing a lot of methane. So, I mean, you have to take that into your calculations as well. I mean, you may be creating a bigger problem than you're solving.
That's the first objection that one has to encounter. And, you have to balance, figure out both sides of the equation. I'm not very good at algebra, though. So.
Yeah.
Okay, we've already used up way more than our time for this time, but I think we're going to come back to this one because I think it's a very key question, really. Is it possible to get there where we need to go just by reducing emissions, even if we break our necks doing it as fast as we can? Frankly, I don't think it's possible. I think we really have to do that and actual removal of carbon from various ways. Everything from crushed rock you can sprinkle on the ground to maybe iron filings in the ocean to, God help us, maybe shooting sulfur into the stratosphere. I'm not quite sure what all has to be done, but I think it's more than just emission reduction. And we have to come back to that question probably, because you and I are going to have more conversations about this. Okay.
We're gonna blow through 2 degrees C probably in the next 20-25 years. But we can bend the curve and we can get on I believe, Craig and I believe that we can get on a path that will lead to the elimination of greenhouse gas emissions over, let's say, the next 40-50 years.
But everything you've said so far says the opposite. Yeah. Everything that you've pointed to says there are all 5 or 6, you've mentioned at least 5 different tipping points that could occur in various ways, and that we're approaching those tipping points every one of them, we're approaching them.
Oh,
Therefore,
absolutely.
when you get this, beyond this 2-degree threshold, we're going to have a runaway catastrophe, bar none. I mean, it's going to be beyond anything anybody thought of. So it's not just a matter of keeping it to 2 degrees. It's a matter of keeping these tipping points from throwing us into total oblivion.
Well, one thing a good topic, and again, this may not go into your, is really mitigation, because we know that we're going to have it's going to get worse before it gets better. And a big thing is going to have to be, what do we do? I mean, if we assume the ocean's going to be rising, maybe an inch a year or something like that, what if the monsoon fails and things like that? We really need to be thinking about what are we going to do to mitigate the consequences of those changes. Mitigation has got to be a big part of the solution, because we've done a lot of damage, and there's a lot of damage already because of latency already baked in. No matter what we do, we will have to deal with that over time.
Okay, well, this is a pretty important issue.
And I think it's a very important issue, yes.
Absolutely, absolutely.